Hello, candidates. Very good evening. This side Ankit, and I hope I'm audible to everyone. Kindly, please confirm me once again, guys. Am I audible to everyone? Hello, Vijay. Hi, Tarun, Sarath, Nisarg, Neha. Let me just share my screen. Audible. Very good. Okay, so guys, how overall your preparation is going on? Just let me know. Okay, so let me just share my screen. And on today onwards, like we are going to cover the multi-model approach, right? So I hope my screen is visible, right? Let me just open a new notebook in a drive. Okay, go to this file, new notebook in a drive, right? Okay, how like the candidate we have already completed knife-based machine learning model, linear regression, logistic regression, and your previous trainer has already completed the KNN, which is K nearest neighbor. If you are not familiar with the KNN part, guys, just let me know, right? I'll try to repeat this again. Just let me know in the comment or like in the message box how many of you are already familiar with the like KNN part, because I am told that that part was already covered, right? Just let me know in the comment section, right? Okay, so on today onwards, we are going to understand the multi-model approach, and the model for the today is decision tree, right? Decision tree ML model. Okay. Before we just understand this, what exactly the decision tree, we have to understand the mathematical intuition and the overall context of this ML model, right? So if you want to do it parallelly, let me just share this. You can do the practice parallelly, right? Okay. Okay. I have shared the Google Colab notebook link. If you want to do the practice parallelly, you can do this, right? So today model that we are going to understand is decision tree in ML, right? So decision tree is again a supervised machine learning. You can just write the definition. It's a supervised ML or algorithm, and we can use it for both regression problem and classification problem. Let me just make it more clear. We know that we have two types of regression problem now. The first one is simple regression problem, and second one is multi-class regression, not multi-class, it's like multiple linear regression. The first one is simple linear regression, and second one is multiple linear regression, right? And with the help of this decision tree, we can solve the problem of both regression problem and the classification one. Inside regression problem, we know that we have simple linear regression and then followed by the multiple linear regression. But in the classification, again, we have two different sort of problems. The first one is binary classification. We already know that, right? And second one is multi-class classification. Multi-class classification, right? So we can use decision tree machine learning model to solve any sort of problem, whether it is regression problem or like the classification one, right? So before understanding this decision tree, let's just understand what exactly the decision concept is and how to implement the decision concept with the help of some sort of tree model, right? Let me just open my paint. And suppose let's just consider one scenario where we are not getting the enough sale for our company. Okay, the company generally manufacture or assemble laptops. Okay, let me just take an example of Asus laptop, right? And the problem that they are facing, they are not getting the enough sale. Guys, just let me know. My screen is visible or am I like I'm properly audible or not, right? So the company is facing some sort of low sales issue. Okay. Now we know that we could have low sales issue due to different sort of kind of problems. Okay, so let's just divide the low sales issue into multiple sort of cases. First, second, and third. The low sales problem could be due to poor quality of the product. Okay, we are just creating a decision model, right? Poor quality of product, low sales due to lack of vendors or outlets, right? We can just simply write this. Or this the low sales is due to lack of marketing and budgeting. We can also write this one, lack of marketing and budgeting. Okay, so we are just creating a decisions nodes, right? Why exactly we are getting the low sales? Okay, now if we just pick this poor quality of product, suppose we are considering this one problem, we have multiple problems, but we are just trying to deep dive why we are getting the poor quality of product. Okay, so again, the poor quality of product can be due to multiple set of problems, right? Let me just write one of them. It can be due to uh, like uh, poor vendors, poor vendors. Okay, and it can be due to low budget, low budget of what? Low budget for accessories. Okay, low budget for accessories. So that is because of the low budget of accessories, we are getting some poor vendors or like some poor quality of product. Okay, this can be the issue, right? Why we are getting the low budget for accessories? So again, you can just further deep dive this problem. It can be due to low investment or like low set of like investment and marketing sort of like this. Okay, so let me just break down this into low investment. Okay, so guys, just understand one thing here. We have created one sort of pre-structure model, and the model is like why we are getting low sales or low sales problem we are facing with the company. So we have just divided into different sort of decision nodes, right? In the same way, machine also perform the same task, right? But before understanding the decision tree, let's just give some naming convention of what exactly all these are. Okay, so the first node, whatever the first node that generally play a crucial role is like the overall problem. So you can just simply say the first node, we generally refer this first node as a root node. Okay, so let me just write a name of this. The first node, we refer this first node as a root node. Root node is like the main node or like the principal node. Based on that particular node, your all rest decision tree completely based, right? So this one is like your root node, right? Now, whenever you are getting the final answer, now where we are not getting any further bifurcation, it's called the leaf node. Okay, that one is like your leaf node. So let me just give a color of this green one. That one is like your leaf node. This one is also your leaf node. If you're getting the final answer, na, that one is your leaf node. So let me just give the name for this. It's like your leaf node. This one, that one, and this one also. Why we are considering this as a leaf node candidate? Because this one is the final answer node, right? So you can just say if we are creating any decision tree kind of structure now, so the first node generally referred by as a root node, and the like last node, you can say the last node is generally referred by as a leaf node, right? It's like the leaf node. Okay, now what about this one, right? So if you just ask what exactly this one, this one is like your decision node. Decision one node is like where you are getting some sort of decision. This one is your decision node. Even this one is also like your decision node because this one is the second decision, that one is first one, and this one is third one, right? So you can just say all these are your decision node, right? So that blue color, like the brown color, this brown one, and that one is the decision node. So guys, if we are creating any decision tree kind of structure, so we have to follow decision node. So we have to follow this sort of structure where the first node generally represented by the root node, the last node generally represented by the leaf node, and the channels where multiple decisions we are getting is called the decision node. Sometimes we also refer this decision node as a branch node. Why we are considering this as a branch node? Because Here, this decision node, we are getting some multiple branches like branch 1, branch 2, branch 3. That is the reason we generally refer this as a branch node, right? I hope everyone is getting my point. Guys, just let me know. Are you getting my point? Candidates, all candidates. So this same behavior, we just try to mimic the same behavior using ML model. And if we are just considering the same approach, na, our decision tree model generally using the same approach. And that is the reason we are saying this as a decision tree. But we have some sort of problem. How to identify which node is a root node, which node is the leaf one node, and what about the branch node? How to just identify which node can be which one, right? So for that, you have to apply some mathematical concept and the mathematical intuition behind this machine, decision tree in ML, right? So let me just show this first. Let's just take one data set. We have very popular data set, and the name of that data set is called play tennis data set, right? Okay. Inside this play tennis data set, first understand the problem, right? Then we will probably understand how to create the decision node. Okay. In this dataset candidate, we have four attributes. If I am referring attributes now, so attributes generally refer as a features. Now we are getting some four features. The first feature is like the outlook column. Second is like the temperature column. Third is the humidity, and the fourth one is windy one, right? It's completely based upon the players. Like if we are getting any sort of input, whether the player going to play the tennis or not, this is some sort of very basic classification problem where we just take some input like what is the outlook, it's like rainy outlook. What is the temperature of like the overall surrounding is like the mild temperature, the humidity is like the high, the windy is like false is like there is no such huge like the gust of wind is flowing, you can just simply say. And if the like whether the player like to play the tennis, yes, the player like to play the tennis. So this one is like the very basic classification ML problem where we have the four features. We generally refer four features as an attribute and the one output or like the target column, which is whether the player will play the tennis or not, right? And we are getting some sort of yes or no. And I can just simply say this completely based on the binary classification. Where why? Because we are only getting the answer is either yes or no, right? I hope everyone is getting my point, right? So can it let me just take a screenshot of this. Now, based on this, we need to understand how to create a decision tree model for this one, okay? And how to just identify which node can be my root node, okay? And which node can be the leaf one node. For that, we need to understand the mathematical intuition behind this, okay? Now, before just directly jumping to the mathematical part, let me just ask some question. The question number one, you have four candidates that they are like generally you have to select or like you have to just select the right candidate for the prime minister like phase, right? So the first candidate is like candidate one. Candidate one is like their let me just take example of their IQ like the mental state, okay? Mental state. If I am referring the mental state as one, it means like 100, it means the good mental state, okay? So the candidate one has a 100% of mental state, right? Okay. The, you just need to just let me know which candidate you generally prefer for a PM candidature, right? The candidate two, and the mental state is something like the 50%. 50% they take right decision and 50% they generally take wrong decision. Same as it is with the candidate three. Candidate three, the mental state is like something 20%. Okay. And the last one is like the 10% or the 0%. Okay. Candidate four, mental state is like 10%. Let me just take the example as 10%. Now you just need to select the right candidate for the PM candidature. Now just let me know which candidate you generally prefer. Everyone just write your answer. The candidate A, candidate B, candidate C, or candidate D. You're getting the corresponding mental state, whether they are able to take the right decision or not. Candidate one is like 100% mentally fit. Candidate 2 is 50% mentally fit and 50% not fit. Candidate 3 is only 20% fit, and candidate 4 is 10% fit. Just let me know. And everyone, I think, will select the candidate one. Very good, right? Why everyone is selecting the candidate one? Because it has the complete state and the complete good IQ, or like you can say the complete mental state, right? That is the reason you are considering this candidate was one as a PM candidature, right? So you are just somehow checking the candidate has 100% quality. So we have to calculate the impurity, right? Now let's just take another example. We have four different like dishes. The dish one, D1 is like, you just need to check the impurity level, right? Okay. And the dish are like something pizza. Okay. Pizza is the fast food dish. Let's just take this example like fast food. Okay. And we have some sort of level of impurity in each pizzas, right? So the first pizza one, P1, has the impurity level of like something impurity level, right? It's not the purity level. The impurity level is something like 100%. Okay. Same with the pizza 2. The instead of impurity complete one, I'll just simply write the IP. IP is like the impurity. It's like the 50%. And same, the P3 pizza 3 IP is like the 20%. And now in this P4 case, the impurity is like the 0%, which is ideal. You cannot get the 100% pure pizza, right? So it is like, let's just consider this as an ideal case. Okay. And let me make this as a 10% of impurity. Now, in that particular question, everyone selected the candidature one as a PM candidature because they have like their mental state of 100% correct. Now, in this one, guys, let me know where each pizzas are getting their impurity level. The first one is like 100% impure. They are not pure, right? They're not even 1% pure. The second is like the 50% pure. Third one is like the 20%, and the fourth one is like the not pure. Like it's like the impurity level is 0%, right? The third one is like the impurity level is 20%. It means 80% purity level, right? Now, just based on this fact, let me know which pizza that you are going to select candidate. Now, in this scenario, just let me know, everyone. In the previous question, the answer was question one or like the candidate one. But what about this one? I hope everyone will select the pizza 4. Why everyone will select the pizza 4 candidates? Because it has, just write down your answer, class, because it has the impurity of 0%, right? So in the same way, we have to check the impurity of the each class. Based on this data set, now we have to calculate the impurity. Then we can simply select the root node. So let me just write this. One who has or have the lowest impurity. One who has up the lowest impurity is the right candidate for root node. You can just say, or instead of writing this, lowest the impurity level, better the root node it will be, right? So guys, I am writing this like, you just need to calculate the impurity level. If you are getting the high impurity level, it cannot be the root node, right? It cannot be the root node, right? Instead of node, it should be node, right? And if you are getting the highest impurity level, then it cannot be the root node, it will be the leaf node, right? And if you are getting the lowest impurity level, then it will be the root node, right? So how to identify which node can be the which one? So the root node is only if they have particularly the lowest impurity level, right? So in the same way, we just need to calculate the impurity level. How much data is impure, right? Now let's just take the example of this. We generally refer this as impurity level mathematically, and that is called Gini impurity, right? If I want to build build my ML model using decision trainer, so we have to calculate the same level of impurity, but that mathematical representation of this impurity is called the Gini impurity, right? How to calculate this Gini impurity? And let's just take first example of this Gini impurity, right? It's like GINI, okay? So this example is the good one, right? So the impurity is like the randomness in the data set, okay? Now let me just ask some question. Class, what is the probability if I have this bag? What is the probability of getting one ball if I'm picking one ball out of this overall box, whatever the balls that we have, 1, 2, 3, 4, 5, 6, what is the probability of getting a ball and it is blue in color? Just write down your answer, everyone. What is the probability of getting a ball of blue color? What is from this box? Everyone, if I am picking or like drawing any ball, what is the probability of that ball will be in the blue color? Just let me know. What is the probability? 1. Why everyone is saying 1? Because we know that this box contains only blue color of ball. So can I say that this box has zero randomness? Zero randomness is like there are no mixed set of different balls available right here, right? Whatever ball I'll generally pick, it definitely will be 100%. Now, this the question will remain same likely like this. What is the probability of getting Tuesday tomorrow? Everyone will know that, right? If today is Monday, the probability of getting Tuesday is 100% tomorrow, right? So in the same way, if we're getting any irrelevant data in a set of data, that increase the randomness, okay? And that the more the randomness increases, the impurity level also increases. Can I say this? Right? Right now, this entropy, like right now, this system has zero entropy or like zero randomness, right? Why it has zero entropy or zero randomness? Because there are no such different data set available right inside this box. In the same way, now just let me know what is the probability of getting the one ball and it is blue in color in this second box. Everyone, just give me your answer. Now again we have 1, 2, 3, 4, 5, 6 balls. And what is the probability of getting the blue color ball? If I just simply pick one ball, right? Just write down your answer, everyone, candidate. Look at this image. Very good. The probability of getting the blue color, one ball blue color is like 5 by 6. Now, can I just say this box or like this bag has some entropy, but the entropy is very less for red one and very like the entropy is very less, right? Because of the less number of balls, red color balls available in this box, right? So it is like somehow similar to the number of different classes. If we are getting a complete one class, it is like the 100% single grain. It's like the complete rice box. So I can just simply say there is no such mixture of any other data set. It means the impurity is 0 and the purity is 100%. It's like 24 karat gold, right? And why if we are saying 22 karat gold, it means there are some sort of impurity that we are applying over the metal of or like the gold metal, right? So we need to calculate the impurity level. Now, what about the impurity of this box? Now you can just say the probability of getting the ball, red ball is again the 3 by 6 or like 1 by 2. And the probability of getting the blue ball is also 3 by 6 or like 1 by 2. So can I just say, candidate, one thing, the impurity of this box is 0 because whatever ball I'll pick, it will be blue in color. The impurity of this box is somewhat in like more than the previous one, and the same as it is the impurity of this one is will be far more than the all the previous one. Can I say this statement? Can you just let me know, class, everyone? Just let me know. Can I say the impurity of this box one is far more greater than the rest of the boxes? Why? Because we are getting the different classes right now. Okay. So that makes like this. If we are getting multiple classes in just a single data set, it increases the impurity. If we are getting only one class at the given data set, it means the impurity is 0. Just let me know if it is, if you guys are understanding this concept. Class, let me know fast, right? If the data set has like different classes in a container, the impurity level also increases. If we are getting one data set per box, so the impurity levels also decreases. In the same way, the impurity level is 0. Impurity, we have some sort of impurity here, and the same way we have like very high much amount of impurity right now. Okay, now we need to first of all, we need to understand the concept, how to convert this into the mathematical one, because this is the theoretical concept right now. So we have a formula for this, and the formula, generally we refer this formula as a Gini index. Okay, and the formula, let me just take an example of this, right? And what I'll do, Gini impurity play tennis formula. Okay, we have to calculate the Gini impurity. Okay, and there is a very particularly popular formula for that. That is one minus probability of each class, right? So play tennis Gini index, GINN Gini index, play tennis Gini index, GINI Gini index, right? Okay, just take the reference of this article, right? I'll give you the link of this article, and you can just also take the reference for future better understanding, right? Okay, this article is very important, right? Let me just go to this. Where's the image? Where's the article? The article is there, right? Okay. So now let's just understand the formula for Gini index, and then we'll probably try to calculate the Gini index as well, right? Okay. Now, again, we are starting with the disease entry. Okay. Now let's just take an example. Suppose I'm asking just a simple question, guys. Are you tired? If the answer is yes, then I'll just say go and sleep. If the answer is no, then I can just say, okay, you can play. So this is the very decision node, like very basic decision node. Okay. Now just increase this decision node, or let's take another decision as well. So the question will remain same. If you are tired, then you can go for sleep. But if you are not tired, if the answer is no, then you can play. But again, inside the play, you can again ask the question. If you want to play, then you can play a cricket. If you don't want to play, then you can further go for study. So whatever here we are creating, it's like the decision node, or it's kind of a decision tree structure. And we can simply convert this into the decision tree ML model, right? And we need to understand the mathematical intention. That is the reason we are taking this example. Now, here you can simply see that this algorithm simply just based on the if and else condition. If you are tired, go and sleep. If you are not tired, go and play. If you want to play, you can choose cricket. If you don't want to play, you can choose study, right? So this completely based on if else condition. But if we are getting the multiple data, or the data set is very huge, then we cannot simply rely on this if and else condition. Somehow we need to calculate the root node. Right now the root node is tired, right? So how to calculate the root node? Suppose we have different 4 columns now. Can I just say that outlook is the root node? The temperature can also be the root node, humidity can also be the root node, and the windy is one also, right? So we need to calculate which one is the best suitable candidate, or features for the root node, and that's where the Gini index came to the market. Okay, now let's just try to calculate this. Okay, so we need to calculate the top node, and the top node generally is called the root node, right? And then we can further split the further splitation. If we are getting the final answer, then we generally refer this as a leaf node. If we are getting any decision, then then again further bifurcation, then generally we refer this as a decision node, right? Now let's just take the example of that particular same data set. Right now we have 4 different columns, and followed by their final outcome, whether the player like to play the tennis or not, right? Okay, now let's just calculate the decision node, okay, or the root node first. Before just planning for this, just understand one thing. Right now we have the 14 rows. You can just simply count 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and these 14 are called the 14 instances. Okay, because this one is very important if you want to calculate the root node, because it's completely based upon the probability concept, right? Okay, now we know that, guys, we have 4 different features. The first feature is called the outlook, second feature is called the temperature, third feature is humidity, and the fourth feature is wind, right? Now let's just check whether the person will play tennis or not based on any of the features. So we need to select each feature one by one. Then we will check which feature, or which column can easily segregate or separate the tennis decision, whether the player would like to play the tennis or not. Based on each feature, we'll pick one column each column one by one, and then we'll segregate or separate the final class. right? And we'll calculate the impurity of the each column, and whatever has the highest impurity will not consider this for the like the root node, and whatever has the lowest impurity will consider those for the root node. And I have already written the same context, right? Now we generally refer this as the level of impurity as the Gini index and the Gini entropy. So if you apply for ML interview, na, the interviewer will generally ask you what do you understand by Gini index and how exactly this decision tree model works, right? So decision tree model generally need the root node classification. And if you want to calculate the root node, first of all, you need to calculate the impurity, and impurity is nothing, just the measurement or like the mathematical measurement to measure the homogeneity of a feature, like how much feature is like your mixture of different feature. If the feature is very pure one, so it has like the lowest Gini impurity or like the lowest impurity or like the lowest Gini index, right? So we have two different formula to like if you want to calculate the impurity, but the popular one is like the Gini index. And you can also use the entropy as well. Entropy again is like the randomness in your data set. Right now this the entropy of this box is zero, because we are only getting one like we are only getting the blue balls, and that makes the entropy zero. We have some sort of higher entropy and the highest one in this box, right? So you can check the impurity or entropy as well, right? But we generally prefer the Gini index. Now, what is the formula of Gini index? We know that because this is completely based on the probability concept, and we know that the impurity can be the 0, 1, and the maximum it can be 100 or like the 1. So that is the reason we are subtracting the Gini index with the 1. Whatever value that we'll get based on the probability, we have to subtract this from the 1, right? If the like probability or like the randomness value is some sort of 0, randomness is 0, so we'll get the probability as 1. Okay, here you can see that na, the randomness is 0. Randomness is 0, whatever the ball that we will pick, it's completely blue one, and the probability becomes 1. And if you just give the value of probability here, this P is nothing like the probability, and J is nothing, it's a individual class. So it will convert to, or it will become to 1, and 1 minus 1 is nothing, is a 0. So you can say if we are getting the probability as 100%, so the Gini index or like the Gini impurity is 0. It means the system has the lowest impurity. Guys, are you getting my point, right? So we need to calculate the Gini index based on the formula, and the formula is like 1 minus sum of probability of each square, right? So you can just check the probability of that corresponding value followed by the square and just subtract the value from the 1. This is the mathematical formula of this Gini index. Now let's just calculate the Gini index. Before taking all the feature into consideration, we just want to like take an example of like dummy feature. Let's just take this example as mood column. Mood is just a dummy column. It's not the part of the original data set, right? Now, because we want to break down how to calculate the Gini impurity, right? This class is like technically devoted to the mathematical intention of decision tree. In next class, we'll try to solve the problem using the ML approach, right? So the dummy column is like the mood. Okay. Apart from all these 4 columns right now, candidate, we are just neglecting all these 4 columns just to understand how to calculate the Gini impurity. Okay. So we are just considering a one demo column or like a dummy column. Now, suppose in this dummy column, we just simply ask the player, what is your mood? Like, how's your mood? Okay, we'll just go to each player and we just check their mood, right? If the mood is bad, the player will not play the tennis. If the mood is good, the player will play the tennis. So you can just check this simple bifurcation. If the mood is bad, the player will not play the tennis. Mood is good, the player will play, right? So this is the dummy data set. Now, based on this dummy data set, let's just understand how to calculate the Gini index, right? Okay. So we know that now we have the node which is called mood, and inside this mood we have two different split. The first is called good split. Based on mood, we can split the data into two parts. The first one is good and the second one is bad. Now we know that whenever the mood is good, the player will always likely to play the tennis. Here you can check now good, yes. Again, whenever you are getting the good now, the player will always play the tennis, right? At the all area of the good, you are getting the yes, and when it is bad, you are getting the no, right? So we are splitting the data into the good one and the bad one. Now this is very simple if else condition, and let me just convert this, right? Because we have 14 rows of data set, so this is the very root node that we are getting. And again, let me just repeat this again. This is not the actual implementation. We are just understanding how to calculate the Gini index, right? This mood column is not the part of actual data set. In actual data set, we have only the 4 columns and followed by the target column, right? So why we are considering this? We are just taking this for like explanation, how to check if the data set is good, right? So let's just consider this mood as a root node. Now we know that if the mood is good, we have one question, play tennis. If the mood is bad, we have again one question, play tennis. Okay. Now, if the mood is good, the play tennis player will always play tennis, and we are getting 9 times yes. We are getting what we are getting, candidate, 9 times yes, and we are getting 0 time no. Let's just check. Whenever players say yes or like good mood, whenever player has the like good mood, they always play tennis, right? So you can just check 1, 2, 3, 4, 5, 6, 7, 8, 9. So whenever you'll ask them about the mood, and if the mood is good, the player will always play the tennis, and it is correct 9 times. Is there any like data set that say the player has like the good mood, but the player didn't play the tennis? Is there any data set that say something like this? Like any of the rows where the player mood is good but the player will not play the tennis, if it is any data set here, then we'll write the value here. But right now we know that since we have only 14 rows, so we are getting the 9 yes right now. Okay, now what about if the player has the bike, like if they have the bad mood, right? So again you will ask the same question, what about the bad one? Is there any like data set that generally say if the player had like the bad mood, but they also play the tennis? No, we don't have that much of data set, right? So bad mood, we are always getting the no answer, right? Here you can just check. Bad mood, the answer is no. Bad mood, the answer is no. Bad mood, the answer is no, right? So let's just turn this to the decision tree kind of. If the player had like the bad mood, they generally say no, right? So what time or like what is the frequency they said no? So it was like the 5 times. So you can just check 1, 2, 3, 4, and 5. Because we have only 14 rows now, so we have converted the data into 2 split. The first is completely based on the good and the second is based on the bad. Now whenever we are getting the mood as good, the player will say yes 9 times, and whenever we are getting the mood as bad, the player say no 5 times. Now, if you just add 9 and 5, you will get the 14 data set and the data set that we have, right? Now, candidate, I hope everyone is getting my point. Guys, are you getting my point? Is there any question related to this? Anyone? All candidate, just let me know in the message box if you're getting any question, right? Now let's just calculate how to calculate the Gini index for this one. Before directly calculating the Gini index, we have to calculate the Gini index or like G1 for each system. We have G1 like first system and G2 is like the second system. And it's completely based upon the probability. And we know that the formula of this Gini index is like 1 minus summation of each probability followed by their square. So same as it is. So guys, you will calculate the Gini impurity for this G1, like the group 1, and Gini impurity for this Gini index for this G2. Okay. Now let's just understand how to calculate this. So we are calculating the Gini index for the first one. Now we know that the formula is like 1 minus probability of like sum of probability of each square, right? So the first entropy is like the first index is like out of overall this 9 data set. Now we know that now in this good mood we have overall 9 data set, right? And every time the players say 9, so it's like the probability of yes is like 9 upon 9 ka square is like 1 minus 9 by 9 ka square. It's like 1 minus 1, right? And you just again need to calculate the Gini entropy or like Gini index for this one. It's like 0 by the overall data set for this G1 is like G1 is 9, so you are just calculating the 0 by 9. The probability of getting 0, the probability of getting no is 0. So you are just calculating as like 0 by 9 ka square. So it's like 1 minus probability of something yes, like the probability of no. And you are just summing up all the values. And because the 9 by 9 becomes 1, and 0 by 9 becomes 0. So it's like 1 minus 1 ka, 1 minus 1 square, and then minus 0 square. So the answer will become 1 minus 1, and the final answer will be 0. I hope everyone is getting my point, Candiate. Now, in the same way, in this G2, we are only having with the 5 data set, right? Now, let's just calculate the probability of getting yes of this 5 data set. It's like 0 by 5. Okay, very good. Now the probability of getting no of this 5 data set, it's like 5 by 5. Perfect. So we are getting 1 minus 5 by 5 square and minus 0 by 5 square. The 0 by 5 is like probability of yes on this G2, it's like 0 by 5 square, and the probability of no is like 5 by 5 square. And if you just solve all the equation or like the expression, again you will get 1 minus 5 by 5 becomes 1, 1 square becomes 1, and 1 minus 1 is like 0, and 0 minus 0 is like 0. So guys, you are getting the Gini index or like the Gini index for this G1 group 1 is 0, and you are getting Gini index for this group 2 is also 0. I hope everyone is getting the same. Guys, any question related to this Gini index or like the formula? It's like 1 minus summation of probability of each class and then followed by their square. So the formula becomes like this: 1 minus something like this. It's like 1 minus the probability of this to overall context, the probability of this to overall context. And if you just solve this, you will get the formula is like G1 as 0 and then G2 as 0. Now you just need to check the probability or like the Gini index of this complete mood, right? This one is like group 1, this one is group 2. Now how much this group 1 and group 2 able to like make differentiate between yes and no, that becomes the Gini index for this mood or like this for this mood feature, right? So you have to calculate the Gini index for this now, and this one is very easy. It's like G1 multiply by their features and then plus G2 multiply by their features. So you are just calculating this first group able to classify 9 data set. So the probability is like 9 by the overall data set was 14. So it's like G1 multiply 9 by 14. So you are calculating the Gini index for the mood by play tennis. It's like 9 by 14 multiply G1. Why we are getting 9 by 14? Because this group only able to classify the 9 data set. Somehow, suppose if we are getting any 2 values here, so the G1 value will become 9 plus 2. It's like 11 data set by overall 14 data set. So because right now this G1 is only able to classify the 9 data set out of 14 data set, that is the reason we are getting 9 by 14 and then multiply by their Gini index of 1. Because we know that the Gini index of 1 is 0, so it's like 9 by 14 multiplied by 0. Okay. In the same way, you have to calculate the Gini index for G2 as well. In this G2, we are only able to classify the 5 data set out of 14 data set. So it will become 5 by 14 and then multiply by their Gini impurity or like the Gini index. So it's like 5 by 14 multiplied by G2. And since you know that the G1 and G2 both are like 0, so it's like 9 by 14 multiplied by 0 and 5 by 14 multiplied by 0. It's like 0 plus 0 is equals to 0. And that makes this mood as the best classifier. It's like mood is the right node, root node you can generally pick. But in practical situation, we are not always get the impurity as 0. We'll get some sort of impurity. Now, if we are getting some sort of impurity now, for each features, we have to select those who are getting the lowest features. Lowest impurity will become the root node for our the decision tree classification. Candidate, are you getting my point? Everyone, just let me know in the chat message box, class. So how to calculate the Gini impurity? I have already shared you this link, right? So you can just take a reference of this, right? Now let's just remove this mood feature and let's just consider the each feature one by one. Now what we have to do, we have to again repeat the same step with the outlook one, then with the temperature one, same with the humidity and same with the wind. And if we are getting the lowest value out of all the features, we'll pick that feature as the root node. And then we'll repeat this, we will repeat the same concept with the rest 3 features. Then followed by 2 and then the last one 1. And if we are getting the last node, we generally refer this last node as a leaf node. I hope everyone is getting my point, candidate. So this mood was just for example. Now let's just practically calculate the value. Okay. So now how to decide the root node? So we have to calculate the GI for each. each four features, and we know that we have four different features: outlook, temperature, humidity, and wind. So let's just start with the outlook one. Now, how to identify the decision node? So for that, you just go to this data set and just check the unique value inside this outlook column. Inside this outlook column, we have sunny, we have overcast, and we have rain. We are only having the three unique features, so we'll create three decision nodes. Let's just simply pick this outlook as a root node. We are considering, we are just like try to run hit and trial method. What is the impurity, or like Gini index of this outlook, and we will reiterate the same step with all the features. So outlook has like three different unique values. The first one is like sunny, second one is overcast, and third one is rainy. Now we'll ask the same question: play tennis, yes; play tennis, no; play tennis, yes; play tennis, no; and play tennis, yes; play tennis, no. Now, out of 14 rows, if the outlook was sunny, the user likely to play tennis 2 times, and they're not likely to play tennis 3 times. Whenever, if the outside outlook is sunny, the player likely to play tennis 2 times and not 3 times, right? This is the G1 group. Now, what about the G2 group? Whenever the outlook is overcast, the player will always try to deny, I'll not play the tennis, right? So it's like the impurity of this one is 0. Why? Because we are not getting any different class. If we are getting any different class now, just imagine this as a box. Here we are only getting the blue color box, right? Here we are only getting the red color value, or it's like the no tennis value. We are not even getting any one value. So the randomness of this group becomes 0. If the randomness becomes 0, so the impurity becomes 0 also, right? So whenever the outlook is overcast, you no need to even build a ML model. You can just simply say, whenever the outlook is overcast, na, the player will not play the tennis. Can I say this, guys? Is there any value, or like is there any rows that support this features, like the player will also play the tennis when the outlook is overcast? No. That is the reason we are getting only 4 values in this group 2. What about group 3? If the outlook is rainy, the player will play tennis 2 times and it will not play tennis 3 times. Now this one is group 1, group 2, and group 3. Now how we have calculated this candidate? We pick data from here, right? Now just pick this overcast, right? Whenever the outlook is overcast, the player will play tennis 1, play tennis 2, and play tennis 3. So we are getting play tennis 3 and play tennis 4. It's like 4 times we are getting play tennis as 4. So we need to calculate this line. Okay. This one is just for understanding. Right now we pick this as a no, just for explanation, right? It can be yes as well, right? Because this example is somehow related to the previous one, right? Now this becomes group 1, group 2, and group 3. Now we have to calculate the Gini impurity, or like Gini index for each group. Now we know that in this group we are only classifying the, like we are only separating the 5 data set. So the probability is like the 5 one, and it's like 2 by 5 and the 3 by 5. In this one, we are only having the 4 data set. It's like 0 by 4 and 4 by 4. In this, we are again having the 5 data set. It's like 2 by 5 and the 3 by 5. Now, you need to apply the same formula. Let's just calculate the Gini index for the G1. It's like 1 minus sum of probability of each squares. So it's like in this, we are only classifying the 5 data set now. So 1 minus 2 by 5 square and then minus 3 by 5 square. Once you solve this candidate, you will get the Gini index for this G1 is 0.48, right? I hope everyone is getting my point. Now, how to calculate this one? It's like 1 minus 0 by 4 square and 4 by 4 square. Since the 4 by 4 square is 1, it's like 1 minus 1, and the entropy, or like the index, will become 0. So it's like 1 minus 0 by 4 is whole square and 4 by 4 whole square, and the final answer is 0. So it's like the Gini index of this overcast is 0. It's like the impurity is 0. So this can be the participants for the root node, right? It can be the best participants, right? You can say. Now let's just calculate the Gini index for this one. Again, we are getting the value is like 2 by 5 and 3 by 5. So you can just put into the same formula. 1 minus 2 by 5 whole square and then minus 3 by 5 whole square. Once you solve this, you will get the value of like this G3 as 0.48 with the same one as G1. Now we know that if we want to calculate the Gini index of this complete outlook to play tennis, we have to multiply G1 with their probability value, G2 with their probability value, and G3 with their probability value. Now we know that out of 14 data sets, this G1 only classify 5 data sets. So it's like G1 multiply 5 by 14. It's like G1 multiply 5 by 14 plus in this group 2, we are only classifying 4 data sets. So it's like G2 multiply 4 by out of 14. It's like G2 multiply 4 by 14. So, it's like G2 multiply 4 by 14. Now, what about the last one? Again, we are only classifying the 5 data set out of 14. It's like G3 multiply 5 by 14. And you are writing the same. Once you solve this, G1 multiply 5 by 14, G2 multiply 4 by 14, G3 multiply 5 by 14, and you will get some sort of values like this. It's like 0.342. Now you can just say the Gini index of this outlook to play tennis. If user pick this feature, like this outlook, so the Gini index will become something like this 0.34, some sort of like this. It's like the 0.342. It's like the Gini impurity or like the Gini index of this candidate outlook feature. Now you just have to repeat the same step with the rest feature. Guys, I hope everyone is getting my point. Just let me know. Class, let me know in the message box. I hope everyone is getting my point. How to calculate the Gini index of each features. Just write down here, class. Everyone, how to calculate the Gini index of each features. Okay, now just imagine right now we are only getting the 4 features. Just imagine the problem if we are getting the thousands of features. And that is the reason there is a like ML model requirement or like the coding approach requirement is there, right? Okay, now just repeat the same step with the second column. Now we know that the second column is temperature, and inside this temperature we are getting unique values as hot, mild, and cool. So let's just divide this into 3 different decision nodes: hot, mild, and cold. And again, if the temperature is hot, the player will play tennis 3 times and it will not play tennis 1 time. When the temperature is mild, the player will not play tennis 4 times and they will play tennis as 2 times. When the temperature is cold, the player will play tennis 1 time and it will not play tennis 3 times. Now again, you need to calculate the Gini index for this G1, G2, and G3. Now I know everyone is understanding how to calculate the G1, G2, and G3. It's like 1 minus 3 by 4 square minus 1 by 4 square. Why 4? Because we are only separating the 4 data set or like 4 rows out of overall 15 rows, right? So it's like 1 minus yes square, 1 minus no square. It's like 1 minus probability of yes. It's like 3 by 4 square. 1 minus probability of no. It's like 1 by 4 square. Once you solve this, you will get the Gini index of this G1. It's like 0.107. Again, repeat the same with 1 minus 2 by 6 square. Why this time 6 candidate? Because out of this 14 data set, this mild classifies the 6 rows, right? It can separate the 6 rows. So it's like 1 minus 2 by 6 square and then minus 4 by 6 square. Once you solve this, you will get the value of like 0.19. And again, you will repeat the same step. It's like 1 minus 1 by 4 square and minus 3 by 4 square. So you will get the answer is like 0.107, similar to G1 and G3. Both are similar, right? Now you have to calculate the Gini index of this temperature one. And you know that out of the overall 14 data set, this G1 able to separate the four rows out of 14 data set. So it's like 4 by 14 multiply G1 value. So it's like 4 by 14 multiply G1 value plus this G2 only able to separate 6 rows out of 14. So it's like 6 by 14 multiply G2 value. So it's like 6 by 14 multiply by G2 value. Now out of 14, this cold able to separate 4 rows only. So it's like 4 by 14 and multiply by their G3 value. And once you solve this 4 by 14 G1 plus 6 by 16 G2 and then so on, you will get the Gini index of this temperature column is like 0.40. Now you got to know, candidate, the Gini index of the outlook is 0.342. The Gini index of the outlook is 0.342. Let me just write this. Outlook. The Gini index of this outlook is 0.342. Okay. The Gini index of the temperature is 0.404. Okay, 0.404. Now, candidate, in the same way, you will repeat the same step. I hope everyone is getting the point, right? Similarly, you will calculate the Gini index for the humidity one. It's your task, guys. It's your homework to use pen and paper, solve the equation, solve the expression, and then calculate and match with this one. I have already shared you this article link, right? You will get the Gini index as like 0.367. Gini index of the humidity is like 0.367. Let me just write it here. 0.367, right? Okay. And the Gini index for the wind is 0.82. It's like 0.82 for wind. 0.82. Now just let me know which feature has the lowest impurity. Guys, let me know in the message box or like the chat option, which feature has the lowest impurity. Is it temperature, humidity, windy, or outlook? Just let me know here, class, which feature has the lowest impurity or like the lowest Gini index. Very good, Taruna, right? So you can just simply say outlook has the lowest Gini impurity or like the Gini index, and this will be selected as your root node. I hope everyone is getting the point. See, this whole mathematical intuition was to calculate the root node. It was all done to just calculate the root node, right? Why we are considering this outlook as a root node class? Because this has the lowest entropy with comparatively to rest of the other features. The maximum entropy or like the impurity that we are getting is with the windy one. So we'll not select this windy with the root node. We'll select the outlook as the root node, and that makes this decision tree as the root node. Now let me just show this decision tree, decision tree with root node, leaf node, and the decision node, right? And you will get some sort of like this. The first one is called the root node. We already know that, right? The first one is called the root node, then followed by the decision node. We are already familiar with this one, right? If we are getting the final answer we generally refer this as a leaf node or like the terminal node, right? And we have a ML model here, and we'll just simply import that ML model in the next class to build the same decision tree kind of architecture, right? So you can just take a reference of this image as well, right? The first node is called the root node, followed by the branch or like the decision node, and the final node will be like the leaf node. And now in the next class, we'll just try to create the decision tree for play tennis data set. We already knew that how to identify the guys. I hope everyone is getting my point, right? How to select the root node. This is the interview point of view question. Can it? Interview will ask in the decision tree model, how decision tree model evaluate or like calculate the root node. Suppose this is the question, class. Let me know the answer. In the decision tree model, how decision tree model evaluate their root node. Just let me know the answer. Only one liner answer candidate. Rest candidate, just write it here. Gini index. And the second mathematical intuition that you can use is entropy. Entropy is similarly same as the Gini index, just to calculate the randomness in your data set. I have already shared this like article link. Na? You can just instead of this Gini impurity or like the Gini index, you can just again use the formula for this one entropy, and the like the concept will remain same, right? The entropy will be negative. Maximum the negative entropy, minimum the root node it can be, right? So you have to calculate the entropy, right? So this is your mathematical intuition behind this. And here you can just simply check outlook is like your root node, and based on the root node you will calculate the decision node, and decision node then followed by their sub decision node, and finally you will get the play yes, play no, play yes, play no, play yes. It's like your leaf node. I hope everyone is getting my point, guys. Is that clear? Is there any question related to this candidate? Just let me know. This is very important for interview point of view, how to evaluate or how to calculate the root node when it comes to decision tree ML model. Now we already know that decision tree can be used in regression problem as well as the classification problem. So in next class, we'll try to first import this data set, this tennis data set. you can have a like reference of this data set using Kaggle, right? Tennis data set. Once you write this on the Google, you will get the tennis.csv first link. You can just go to Google. If you want to try how to build the model using decision tree, you can just go to Kaggle, click on this download, take a reference of this, and then we'll start with the data set or like EDA part, ML building and all, right? Now, decision tree, we refer decision tree also as a cart algorithm. Instead of decision tree, the interviewer will ask, what do you understand by cart algorithm, right? The cart algorithm is just nothing. The cart represents classification and regression tree. We have a full form for that. The cart is simply as classification and regression tree. Since we know that decision tree can be used in both classification and regression problem, and we are just creating a tree structure. That is the reason we generally refer this decision tree with the cart one. Now let me just go to ChatGPT and I simply ask one question. How decision tree, let me just ask this question, right? How decision tree calculate their first root node? This is the interview question, right? And you will get the answer, right? Let me just, this is the great question. This is the heart of how decision tree work, right? You can just check the like kind of buttering like used by the chat GPT, right? This is the heart of the decision tree. Which feature if I split? And you can just simply check it's completely based upon the Gini impurity or like the entropy concept. And we are using this formula, right? 1 minus something like this. Now it's your task to just try to evaluate with this entropy one, right? Take a reference of chatbot or chat GPT or like any notebook LLM or kind of something this, right? So you will just simply calculate the overall data, and when like if you are getting the lowest value of the Gini index, the best feature it can be for the root node, right? So this decision tree generally refer this as a cart algorithm as well, and you can just ask the question as well. Cart similar to decision tree, right? And this is the final yes. The cart is a type of decision tree because we generally create classification and regression concept here, right? To just trick the interview partner, interviewer generally asks this type of question. Okay, so in the next class, we'll just simply try to build the ML model or like the actual implementation of this decision tree. In this class, we have just like understood the concept of how to understand like how to implement the decision tree structure, what exactly the mathematical intuition behind this, and how they evaluate, how it calculate the root node, decision node, and then followed by the leaf node. And then we'll start the practical implementation with the same dataset, 10 years dataset on the next class. Guys, is there any question? Just let me know here. Or shall we close this session, guys? I hope everyone is getting my point. What exactly the mathematical intuition behind the decision tree, right? Guys, is that clear? Is there any questions or doubt? Let me know. Class, shall we just close this one? Yes, sir. Spurti, Tarunam, Vaishnavi. Okay, so let me just upload this to my GitHub profile. I hope everyone is familiar with this one, right? I'll upload and you can just take a reference of this notebook or the rest of the code. And I'll upload the data set as well if you want to try, right? And let's just connect tomorrow. Okay, candidate? Is there any question? Just let me know. Okay, let me just share this. Let me just stop this and we'll connect tomorrow, right? Okay, candidates. Bye-bye.